Here we have a Gigabyte 4070 video card that came in for repair. We already disassembled the board. And in case the customer is watching, ticket number is 120860. Let's read what the customer wrote. The customer said, referral internet, description. Please find which component burned out. Stopping my GPU from showing video. I need the exact capacitor component that failed, please, as I have 2 more of the same GPUs. What kind of talk is this? Every device is different. Every repair is different. If I told you which component failed, what's going to happen next? You're going to go and fix it yourself? How does that work? I'm making a video on this so you can see the exact component that failed on this card. Everything I do is shared on YouTube so you can know the exact issue, the exact problem, and the exact component that failed. I do not hide anything from anyone. Of course, I do not make videos on every device, but if I'm making a video, you can see the exact component that is failing. I fix EVGA cards every day, EVGA 3090 cards, and I have one on my bench right here. They all fail for the same reason, a short circuit on the 12-volt line, but every time it's a different component that fails. There's no such thing as exact. It failed because of one specific component. There's no such thing. Let's take a look at the card. A capacitor, the exact capacitor. I haven't seen a capacitor fail on any video card since I started fixing video cards. Resistance mode, or maybe we can go to diode mode. Let's start by measuring our 12-volt line, 0.472 voltage drop. .569. If we measure in resistance mode, memory, 79 ohms. Let's measure our 1.8 volts. This should be our 1.8 volt line here. Let me measure in ohms mode. We should have something like 227. I'm reading 251 ohms. That's good. Close enough. And let's measure our PCIe 12V in ohms mode. I'm reading 498 ohms. Measure down here. No short. And measure our 3.3 volt line. We do not have a short. So for the most part, measurements are good. Quick visual inspection so we can find the exact issue for the customer. Otherwise, if we do not find the exact component that made this card fail, we're not going to be able to fix this card. Let me measure this fuse here. And 0 ohms. The armases, no issues. Flip the card, look on the back. We're going to inspect the data lines. Because as you know, a customer who want to know exact, they probably tampered with the board. They probably opened up the video card so they can inspect the inside. How many times did I say exact in this video? And you're going to win $1 million in Monopoly money. And by the way, somebody sent us $1 million in Monopoly money. He sent us like $40 million in Monopoly money. Because I did promise others in previous videos, if you guess the answer, I'm going to pay you $1 million. And then I mentioned Monopoly money. And we had a lot of viewers asking for the price. So I said in the following video, I do not know if they even make $1 million in monopoly money. A few days later, we received a mail with $1 million in monopoly money from a viewer of the channel, and he sent us like a bunch of them. So maybe the winner will get a signature on that monopoly money, and I'll mail it to you. That would be fun. And then if you keep that monopoly money for 5 more years, you're going to sell it for $1 million. Win-win. And you're going to pay me half. Right? That guy is not humble. Who does this guy think he is? All right. Visual inspection passed. Diode mode passed. Ohms mode measurements passed. Now we're going to plug in the cord and we're going to measure it in voltage mode. Okay, so we did get a chirp. Black screen, but we did hear that chirp. 1 beep and then 3 beeps. What does that mean? 1, and the 3 beeps were actually not too fast. Toot, toot, toot. I do not know what that means. It's posting, but black screen. Let me turn the power supply off, and I'm going to turn it back on and quickly measure some voltages. Power supply on. Meter in voltage mode. Oh, now the 3 beeps are faster. We have 12 volts. Do we have 5 volts? We do. Memory 0. Let me turn the power supply off. Back on and measure memory quick. Do we have memory? And we do. 1.3 volts. 1.3 volts. Now it took a while for the card to post. Something strange is going on. We do have 0.9 volts. Our PCIe voltage 12, we do have it. And our 1.8, I'm reading 1.214. Wow. We have 1.2 volts right under the memory chips. Right here. That's supposed to be 1.8, right? I mean, we did measure it in ohms mode, and we got a 250 ohm reading. Sounds like the 1.8 volt line. What is 1.2? Power supply off. I do not fix 4070s on a regular basis, usually 4090s. We get fewer of the 4070s. But we should have 1.8 volts here. We are reading 1.2. And what is this chip? The GS9219. I do have it. I do have 9219. Maybe the chip is not outputting the right voltage. I do not see any broken components here. Nothing damaged, no corrosion, no liquid damage. And if we flip the board, right behind the coil, the board looks super clean. The board looks clean. So without wasting any time, so we can pinpoint the exact problem to the customer, let's go ahead and replace this chip and see what happens. Do you need to add flux to desolder a component? No, because I get this question all the time. Sometimes I apply flux when desoldering, and other times I do not apply flux. Flux just helps with the flow of solder. Sometimes I do feel that flux helps with desoldering the chip faster. but that's not the purpose of Flux. I'm working on a thick board here, so anything that would help remove the component faster, I would use. The chip is out. Now we're gonna apply Flux so we can make those joints nice and neat. If we applied solder without Flux, then we're gonna have bridges and everything's gonna be a mess. With Flux, everything will be nice and neat. That's basically Flux in a nutshell. Somebody in the comments mentioned that to apply the right amount of solder to the pads, I can soak my braid wick with solder and then I can brush the braid wick over the pads while applying hot air, and the right amount of solder will transfer over to those pads. That guy is like master level guru. No. How about no? The right amount of solder is not really a concern for me. The more solder, the better. If it squeezes out, we clean it. I mean, how awkward is it to first apply solder on the wick, make sure the wick sucks all the solder, then use the wick and hot air station, and then brush that wick on the board, possibly knocking off components on the board because of hot air. Why do people do this? Why do people want to reinvent the wheel? If it's something that's gonna save me time, I'm all for it. But something that's gonna take me more time to do, because I want to apply the right amount, the perfect amount of solder on those pads, no. And then what we can do is this. And we are done. Solder and wick and hot air and brush and 60 million steps so I can apply the perfect amount. I have access, I remove it like this. 2 seconds and I'm done. That's why components are placed next to the chip. So we can transfer excess solder onto them. Now it's okay if those pins bridge because they're all connecting to the same pad. My wife is calling. She's calling me at the wrong time. I tell her that you always call me at the wrong time. And she tells me there's no right time. It's always the wrong time. She hung up. Look, I called somebody else. She's right there. She heard what I said. I cannot believe that she called me while she was standing behind me. She wanted to see what I would say. Okay, so we're gonna measure now. Do we still have 1.2 or? Power supply on. And we still have 1.2 and a chirp. So what is this rail? What's 1.2? I do not get it. Excuse my ignorance, but I would have thought that this line is 1.8. What's 1.2? We have 12 volts here. 12. 1.2. 0.6. 3.2. 3.2. 0.6, and we have nothing here. I need to open up the data sheet for this chip so we know what each pin does, and then we'll take it from there. I do not have any schematics or board view diagrams for this card, so I don't know if we can figure it out. I may post this video if we do not figure it out, and then maybe somebody out there may have schematics or a board view diagram. I need the board view diagram more than schematics. Flip the card. $12 volts. And all those caps I'm not concerned about. Interesting. We have 6 volts here. And we have 6 here too. $1.2. 12. 0.8. $1.2 on both ends. I'm just reading out the numbers loud in case someone out there knows what's going on. $5 volts. 5. We have 0 here, and we have 5 here. Is that normal? 5 volts here and 0 volts. Actually, no, I'm reading 5 now. Okay. I did not have a good connection measuring that resistor. So what is the problem? Let me turn off the power supply. Back on, and we're gonna measure core. 0.92. 0.92 is not good. 0.91. And then it should go back down to 0. I'm still at 0.92. GPU is hot. Yeah, 0. We do have memory. We do have 1.2 volts, whatever that is. We do have 12 volts. We do have 5 volts. We do have 3.3 volts. And the card posted 1 and then 3 beeps, 0.9 core, and no image. I'm gonna put this one on the side. I have a lot of things I need to get done on the bench. And tonight I'll look for a board view diagram if I'm able to find one. If you do have one, send it to me so we can continue with part 2. Otherwise, I'm gonna have to figure it out manually if I can, or if I cannot, then we're gonna have to mail it back to the customer as a no fix. Let me know, and I will see you again in the next video.